Our today's lesson is slope condition for perpendicular lines in the coordinate plane. Recall from the previous lesson on perpendicular lines that there are two lines whose intersection forms a right angle. In the coordinate plane, two lines that are perpendicular have slopes that have a product of -1. It does not matter if they have the same or different y-intercept. Without graphing, which pair of equations represent perpendicular lines? You're not concerned with the y-intercepts. You're looking at the slope. So in this case, I have a slope of 2. I have a slope of 1/2. 2 times 1/2 gives me 1. But that's not -1, so it can't be A. My slope is 1/4 and 1/4 here. So the product of 1/4 and 1/4 is 1/16. That does not give me a slope of -1. And here I have a slope of -1/2 and 2. -1/2 times 2 gives me a product of -1. Therefore, these two equations are perpendicular. Without graphing, which pair of equations represent perpendicular lines? Now these equations are in standard form, so sometimes you have to switch them over to slope-intercept form. So let's look at A. If I were to switch that into slope-intercept form, I would get this for the first equation. Second equation, I would get this. And -2 and 2 have a product of -4, so that's not, these two lines aren't perpendicular. If you look at B, if I were to switch this into slope-intercept form, I get y equals -3x plus 1. And if I switch this over, I'll say -3y equals -x plus 6. So y is going to equal 1/3 x minus 2. So let's compare 1/3 and -3. 1/3 times -3 does indeed give me -1. Therefore, we know these two equations are perpendicular. That concludes my lesson for today.